So much of our modern technology feels like magic, right? But behind all those screens, there are these true wizards. We're talking about a group of elements called rare earths. They're pretty much the invisible ingredients powering our entire modern world.
Okay, so let me ask you a question. What could a fighter jet, a massive wind turbine, and the smartphone in your pocket possibly have in common? I mean, they seem like they're from completely different universes, but believe it or not, they all depend on the exact same group of extraordinary metals.
So, first things first, let's just get this out of the way. That name, rare earth, it's actually a huge misnomer. And you'll see that understanding why it's so misleading is really the key to this whole story.
So what are we talking about here? Well, rare earth elements, or REEs, are a group of 17 metals on the periodic table. You've got the 15 lanthanides plus two others, scandium and yttrium. And what makes them so special are their incredible magnetic and optical properties. And this brings us to the central paradox. Geologically speaking, they're not rare at all. In fact, the most common one, cerium, is actually more abundant in the Earth's crust than copper. The real problem, the thing that makes them rare, is economic. They're scattered all over the place, and you almost never find them in these nice concentrated deposits that are easy to mine. That makes getting them out of the ground incredibly difficult and expensive. And just to really drive this point home, think about this. Even the least abundant rare earths are still almost 200 times more common than gold. So again, the issue isn't that we can't find them. It's all about the crazy economics of getting them out of the ground.
Okay, so we've debunked the rare part. Now, what do these things actually do? Well, the short answer is pretty much everything that makes our modern world tick.
Just take the phone you're probably holding or have nearby. You know that little buzz when you get a text? That's a tiny motor powered by a neodymium magnet. The super vibrant colors on your screen, that's thanks to yttrium, europium, and terbium. The camera lens uses lanthanum to keep pictures sharp, and the glass itself was probably polished with cerium. Your phone is literally saturated with these elements. But out of all their uses, one application is absolutely king: high-strength magnets. And get this, in 2022, these magnets made up less than half of the total volume of rare earths used, but they accounted for a mind-blowing 96% of the entire market's value. That's where the real money is.
And, that kind of economic power, it translates directly into military power. We're talking about immense strategic importance here. A single Virginia-class submarine needs about 4,600 kilograms of this stuff for its sonar, guidance, and motors. An F-35 fighter jet uses over 400 kilograms for its advanced targeting systems. There's no way around it. Modern defense is completely dependent on them.
So, you can probably see where this is going, right? This critical importance creates the central conflict of our story. When a single country gets a virtual monopoly on materials this vital, it creates an incredible geopolitical vulnerability for everyone else. Which leads to the obvious question. So where does the world actually get these critical materials? You'd expect a nice, diverse global supply chain. The reality, however, is the exact opposite. If you look at just mining, digging the raw ore out of the ground, China is the undisputed leader. They're pulling up nearly 70% of the world's entire supply. But as big as that number is, that first step, it isn't actually the most critical one.
Okay, this is the real chokehold. See, mining the ore is one thing, but separating those 17 different elements from each other is an incredibly complex, expensive, and frankly dirty process. And in this midstream processing and refining stage, China's dominance is absolute. They control something like 90% of the global market. To put that in perspective, even the ore that's mined right here in the US has to be shipped to China for processing.
And look, this isn't some theoretical what-if kind of risk. This dominance has been used as a geopolitical weapon. Back in 2010, China restricted exports to Japan during a dispute, and it sent global markets into a complete panic. And just recently, they've banned the export of the technology needed to process these elements, doubling down on this dependency.
But the geopolitics, that's only half the story. There's another, darker side to this. We always hear about rare earths in the context of green technology, right? Things like electric vehicles and wind turbines. Well, here's the massive irony. Producing them is one of the most environmentally destructive industries on the planet.
There's this quote that it hits the nail on the head. The global transition to supposedly clean technologies is directly fueling one of the world's most polluting and socially destructive industries. It's this really stark paradox, isn't it? Our push for a cleaner future here is literally fueling environmental devastation somewhere else.
And the environmental footprint is it's staggering.
For every single ton of finished rare earths you produce, the process can generate up to 2,000 tons of toxic waste. And yeah, that waste is often radioactive.
So how does it get so bad? Well, a common method is called in situ leaching. Basically, you drill holes into a hillside and you pump a cocktail of chemicals, like ammonium sulfate, straight into the ground. These chemicals dissolve the rare earth elements, and then you collect this toxic slurry at the bottom. It's cheap, it's effective, and it absolutely catastrophically pollutes the soil, the rivers, and the groundwater for miles around.
So, let's recap. We've got a dangerous geopolitical chokehold on one hand, and a massive environmental crisis on the other. It's a pretty bleak picture. But this double-edged problem has sparked a global race to find better, safer, and more sustainable solutions.
And believe me, the search is urgent, because if we look ahead, the demand for those key magnet rare earths, the ones for EVs and wind turbines, is projected to triple by 2035. And our current supply, it's not going to keep up. We're looking at a massive potential shortage.
So, what can we do? Well, one of the big hopes is recycling, or what some people call urban mining, getting these elements back from old electronics. Right now, our track record is terrible. We recycle less than 1%, but there's a lot of new tech being developed. And if it can scale up, recycling could potentially satisfy a quarter, maybe even 30% of our future demand. Another strategy is to just innovate our way out of the problem. You've got companies like Tesla and BMW that are designing electric motors that don't need these powerful rare earth magnets at all. Now, sure, there can be some engineering trade-offs in size or efficiency, but it proves that substitution is possible. It shows how these supply risks are actually a powerful driver for innovation. So when you put it all together, the West's strategy to deal with this is really a four-part plan. First, diversify mining by working with allies like Australia and Canada. That's called friendshoring. Second, and this is crucial, aggressively building processing plants at home to finally break that Chinese bottleneck. Third, pour money into R&D for recycling and substitution to reduce our overall demand. And finally, use good old-fashioned resource diplomacy to build new, long-term alliances.
Which really leaves us with the big ultimate question here, doesn't it? As we try to build this cleaner, more connected world, can we actually do it without paying a devastating hidden price, both geopolitically and environmentally? These elements are the absolute foundation of our green digital future, but they come with incredibly heavy trade-offs. The real challenge for all of us is figuring out how to harness their incredible power without being crushed by their hidden costs. And honestly, the answer to that question is going to define the next century.